Hello, everybody. Hey, this is going to be a video on going through the answers to the work and energy quiz review. Now, the first question says, what is the weight of the block? And we know that the force of gravity is equal to weight, which is equal to 15.3, which is our mass, times our gravity, which is 9.8. And that is going to be 150 newtons. All right, so 150 newtons is the weight. And in the absence of any other forces, except for the normal force, the force normal is also going to equal to 150 newtons because that's going equal and opposite. Now, what is the minimum force necessary to lift it? Well, we have to overcome 150 newtons. So if it is not moving at all, we just need just a very small and infinitesimal amount greater than 150. And if it is already moving, 150 newtons will make it continue to go up at that speed. So anything above 150 is going to cause it to accelerate. Again, if it starts out at zero velocity, then we need to get it going at least a little bit. Okay, so that would have to be greater than 150. All right, it says calculate the minimum force needed to move the block up to a height of 2 meters. Okay, so if we are lifting this block 2 meters, our work is going to be force times distance times the cosine of the angle, and the force and the displacement are both going in the same direction, so that angle is 0. So that would be 150 newtons times 2 meters, and that is going to equal to 300 joules. And by the way, that work is also going to be equal to the change in the gravitational potential energy. So we're going to have 15.3 times 9.8 times 2 also equal to 300 joules. It says if the block is held there at 2 meters above the ground, if it's not moving, okay, then there is no net work. And therefore that would be 0 joules. All right, moving on. Now we're going to apply 75 newtons horizontally. Okay, so if we now kind of get rid of some of this stuff here, and so if we now have an applied force that's equal to 75 newtons, and since it's horizontal, we're still going to have 150 newtons. That is equal to its force of gravity. Its force normal will equal 150 newtons. And the question is, if it's going to move for a distance of 5 meters with the coefficient of friction of 0. So that means when we go back to applying, our work is equal to force times distance. The force is only working against inertia. It's only working against inertia. So we're going to have 75 times 5, and that is going to equal to our 375. Again, the angle is 0 because they're both going in the same direction. The cosine of 0 is 1. So we're going to get 375 joules. Now, remember that work is also equal to the change in kinetic energy, which is going to be 1/2 mv final squared minus 1/2 mv initial squared. And we made the initial velocity there 0. And therefore, the velocity is going to be 375 is equal to 15.3 divided by 2. So we're going to multiply by 2 and divide by 15.3. And that's going to be v squared. So we're going to take the square root of that. And so we're going to take 2 times 375 divided by 15.3 equals 49, and take the square root of 49, and we get 7 meters per second. So our V final, 7 meters per second. All right, calculate the acceleration. Now the acceleration, we know our initial velocity is 0, we know our final velocity is 7, and we know the displacement is equal to 5, and therefore we can calculate our acceleration using kinematic equation number 4, which is V final squared is equal to V initial squared plus 2AD. This initial velocity is 0, so we're going to have 7 squared divided by 2 times 5, which is going to be, the acceleration is going to be 4.9 meters per second squared. All right, and how long would it take? Now that we know our acceleration, now we can calculate the time. So we could use V final minus V initial divided by A is equal to T. That right there is kinematic equation number 2. So we're going to have 7 minus 0 divided by 4.9, and that's going to give us 1.4 seconds. So the time is equal to 1.4 seconds. All right, so moving on, we are on problem number 10. So now what we're going to do is we are going to change this angle. We're going to change this angle for the applied force. And now, okay, whoops. Now we're going to have this force that is still 75, but now it is 30 degrees above the horizontal, okay? So we're still going to have 150 newtons is equal to the force of gravity. And we are also going to assume that the coefficient of friction is equal to 0.5. Now, again, we're just assuming that that coefficient of friction is both static and kinetic, realizing that there is going to be a difference. Now, what we've got to do before we get into this is we have to figure out the force normal, because some of this applied force is going up and to the right. So we're going to break this down into the force applied in the x direction and the force applied in the y direction. Okay, so we can just do some simple trig there. So our force applied in the y is going to be force applied times the sine of 30 degrees, which is going to be 37.5, or just half of that. And then our force of applied in the x is going to be 75 cosine of 30 degrees. And that is going to be 75 times cosine 30, which is going to be 65 newtons. And now we've got to figure out this normal force. So the sum of the forces in the y is equal to 0. Now, normally the sum of the force is equal to ma, but we know this box, when it moves up and down, it's not going to move up and down because it's just a box sitting on the ground. And we would need at least 150 newtons of force going upwards, and we only have 37.5. So we know it's not going to lift off the ground. And therefore, we're going to have the force normal is pushing up, plus 37.5 is going up, minus the weight, which is going to be 150, and that's going to equal to 0. So our normal force is going to be 150 minus 37.5, and therefore our normal force is going to be 112.5. So we'll call it 113. I think I called it 114 in when we round there, but our normal force, we'll just call it 114 to make this rounding a little bit easier. And again, if you are taking this quiz and you end up with a situation where the number is slightly off due to rounding or just sort of a simple mistake, then you can look for the answer that's going to be closest. So in this case, you would not see a choice. You would not see a choice of, for example, 112, 113, 114. They're not going to be that close. So you're going to pick the one that is closest. All right. So now we have our force of friction, okay? And the force of friction is going to be mu force normal. And since our coefficient of friction is 0.5, we're going to multiply that by our 114, and we're going to get our force of friction to be 57 newtons. Now, that's 57 newtons that way. So if you want to call that negative, that's fine. Again, that is predicated on it being positive in this direction. Okay, so the absolute value regardless is 57 newtons. Okay, so how much work is done by the applied force? How much work is done by the applied force? So we're still going to move it 5 meters, right? So we're going to have work is equal to F d cosine theta. So this is going to be 75 times 5 times the cosine of 30 degrees, which is going to be 0.866. And we are going to get approximately 325 joules. Let me double check that. So we're going to have 75 times 5 times cosine of 30. So 424.75. So 425. Now, since we already know that this component that's going in the x direction is 65, if you just said 65 times 5, you're going to get that 325 joules. So you can do it that way, not necessarily FD cosine 30. All right. So how much work is done by the frictional force? So again, work is going to be done by force, and this time force of friction times distance times the cosine. In this case, it's 180 degrees. So we're going to have 57 times 5 times -1. 57 times 5 times -1 is going to be equal to negative 285 joules. That's the work done by friction. Now, again, you can just not think about this cosine of 180, and you know that the force of friction is going this way, and you know the applied, the distance is going that way, and you can just realize that it's going to have a negative amount of work because those force and displacement are in the opposite directions. All right, so now what's the net work? we're going to take the difference between these two, okay, and we're going to get 325 minus 285, and that is going to give us 40 joules. 40 joules is our net work. Now, if the initial velocity is 0, calculate the velocity after 5 meters. And again, we can do that, okay? We can do that by saying work is equal to the change in kinetic energy, which is 1/2 mv squared final minus 1/2 mv initial squared. The initial squared is going to be 0. So we're going to say 40 times 2 divided by 15.3 and the square root of that. And that is going to be equal to our velocity after 5 meters. And we're going to get 2.3. So velocity is going to equal to 2.3 meters per second after 5 meters. That's with the friction and also that applied force going up at an angle of 30 degrees. All right. Now we are going to we're going to change our orientation now, and so I am going to pause this, erase everything, and put our new diagram on there. All right, ladies and gentlemen, we're back starting with problem 16. Here is our diagram. Now we're going to have a ramp that's still got a coefficient of friction of 0.5, but the ramp has got an angle of 35 degrees. Our applied force up the ramp is going to be 147.4. We're going to have our weight or our force of gravity is still going to be 150 newtons straight down. What we have to determine here is what our normal force is. And so, again, we're going to take the sum of the forces in the y direction. And again, this is not going to levitate off of the ground there. So remember, we're going to make our x direction this way and our y direction that way, because if it's going to move this way, which we'll call this the x, perpendicular to that will be the y. If you don't do it that way, then you're going to have your velocity in components of both x and y, and it makes it much more complicated. All right, so we know that our force, we don't know our force normal, but that's going to be going in the positive direction. So what's going to go in the opposite direction is the component of 150, component of the weight here, and that component of the weight, this one right here, is going to be 150 cosine 35. Cosine 35. So 150 cosine 35 gives us 122.87. So this is going to be minus 123 is equal to 0. Therefore, the force normal is equal to 123 newtons. And that is the answer to 16. Force of friction is equal to mu force normal, which is going to be 0.5 times 123, which is going to be 61.4. 61.4 is equal to our force of friction. Now you can see here that this is not half of 123. It is slightly less because that I rounded up this 123 from 122.87. Okay, so now our force of friction. Now, how much work is done by the applied force? Okay, well, if we're going to move this block up the ramp by 5 meters, okay, we're going to have our work by the applied force is the force applied times distance times the cosine. And in this case, they are parallel, so the angle is 0. 147.4 times 5 is going to give us 735 joules. That would be the work applied. And how much work is done by the frictional force? So the frictional force is going to be equal to 61.4 times 5 times the cosine of 180, or you can realize that they're going in the opposite direction. So this is going to give us the work done by friction is going to equal to negative 307 newtons. And then how much work is done by the by gravity? Now, the work done by gravity is going to be not 9.8, okay? But what we have here is this component right here, okay, which is not 150 times cosine 35, it's 150 times the sine of 35 degrees. And we can see that is the direction. That would be the direction that the force of gravity would be operating when we're going up the ramp. Okay, so we're going to say here 150 sine of 35 gives us 86. So the force of gravity in the x direction is equal to 86 newtons. And so we can say the work done by gravity is going to be equal to 86 times 5 times the cosine of 180. And that's going to be negative 430 joules. And we can now say, what is the net work? What is the net work done? And so we're going to add all these works together, okay? So we're going to get 375 minus 307 minus 430. And once we take into account our rounded answers, the amount of net work is going to be joules, okay? So this would probably really round to negative 305 there, okay? Now, again, that's why we have such a odd applied force number, being very precise, of 147.4. So that when we round it up, we add up to 0. Okay. Now, just because it adds up to 0, no net work, does not mean it's not moving. Okay. So if the initial velocity was 2, okay, it would continue to move. It would continue to move at 2 meters per second. Remember that Newton's first law, that an object in motion will continue in motion unless acted on by an outside force. So right here, all those forces are going to balance. The force down the ramp and up the ramp is going to balance. So as long as it's moving, it's going to continue to move. All right, so we are going to now go on to the last 3 problems, and it's a different diagram. So I'm going to erase and set that up again for you. All right, ladies and gentlemen, we are back with our last 3 questions. So assuming that we were pushing up this block on the other side where this was the angle of 35 degrees, now we reached the top, and now it's going to be moving down the ramp here. And we want to know what is the kinetic energy when it reaches the top if the velocity is still 2 meters per second. So we know the kinetic energy is equal to 1/2 mv squared, which is going to be 1/2 of 15.3 times 2 squared. And that should give us 30.6 joules. 30.6 joules. What is the gravitational potential energy? And the gravitational potential energy is going to be equal to mgh, which is going to be 15.3 times 9.8 times 2.86. So this right here is equal to 150, and 150 times 2.86 is going to be equal to 429 joules, 429 joules. And now the block is going to slide from the top with no friction, We want to calculate the velocity on the other side. This is just a conservation of energy sort of thing. So we're going to have the initial gravitational potential energy plus the, hold on one second. Sorry about that. So we're going to have initial gravitational potential energy plus the initial kinetic energy, and that's going to equal to our kinetic energy final plus our gravitational potential energy final. There is no springs or anything. So we already figured out that this one right here was equal to 429 joules. And then we also had, we're going to call it 31 joules right here. Now, because we reached the bottom, H equals 0 right there, there are our total kinetic energy is going to be the sum of those two, which is going to be 460 joules, which is our kinetic energy final. So now this right here is then going to turn into 1/2 mv final squared. We know that this is 15.3. So we can say 2 times 460 divided by 15.3, and then we'll take the square root of that, and we will realize that we are at 7.7 meters per second is equal to our final velocity. All right, and that is the last question of 25. All right, I hope this was pretty easy for you, and if not, that I ironed out any of the things. So the quiz is going to look something like this, maybe not as many questions, and obviously different numbers, but hopefully you will do well. All right, we'll see you next time.